another. Alright, sorry I had to change these numbers if you didn't notice. So we have this triangle, its sides are 9 centimeters, 12 centimeters, 15 centimeters. We are dilating by a scale factor of 2/3. That means we're going to multiply, right, by 2/3. So the scale factor is, well, 2/3 is less than a whole, right? Like 3/3 would be a whole, so 2/3 is less than a whole. So it's smaller than 1. So the dilation, this one over here, will be smaller. It's going to be smaller. Okay, so the original base was 12 centimeters. The original height was 9 centimeters. Oh, by the way, we're going to assume this is a right triangle. Assume that these are right triangles. And the hypotenuse right here is 15 centimeters. So it's going to be dilated, so we're going to multiply by 3. Oh, by 3, by 2/3. By 2/3. So 12 times 2/3. I'm going to go to Desmos just to show you. So let's get rid of these. I wonder if we can just, yeah. So what do we have? 9 times, well, let's start with the base. 12 times 2/3. So 12 times 2/3 equals 8. Cool. Easy, right? So 8. Centimeters. The height is 9 centimeters. So 9 times 2/3 equals 6. 6 centimeters, and our hypotenuse is 15 centimeters. So 15 times 2/3. Oh, yeah, that makes it easier. Just press divide. Is 10. 10 centimeters. So the side lengths and the dimensions are 2/3, but they're not 2/3 bigger because we're not getting bigger. If you know, we're not getting bigger. We're getting smaller. So it's 2/3 as large. They are 2/3 as large as the original. Let's go ahead and label them, or put them up here. So we get 8 centimeters. We get 6 centimeters. And we get 10 centimeters. All right. So we had a perimeter. Well, there's only 3 sides, so let's get rid of this thing right here. So we will add 12 centimeters, 9 centimeters, 15 centimeters. Let's try that. 12, 9, and 15. Oops. 12, 9, and 15. 12 plus 9 plus 15 equals 36. So that's 36. Well, I can write that a little better. 36 centimeters, like around it, right? And this will be 3 times, I keep saying 3, 2/3 as large. So let's multiply 36 by 2/3. 36 times 2/3 is 24. So we should get, we will get 24 centimeters. So once again, the perimeter will be 2/3 as large. When it's smaller, you're going to say as large. When it's getting smaller, you're going to say as large as the original. Now we have one more. We got area over here. Area is base times height divided by 2, right? For a triangle. And our base is 12 centimeters. Our height is 9 centimeters divided by 2. So let's do this. 12 times 9 equals, divided by 2. Oh, let's go. I think I can put my answer. Yeah, if you click that, it'll take your answer. So my answer was 108, and we'll divide it by 2. And we get 54. 54, remember, centimeters times centimeters, centimeters to the second power. But remember, we will not multiply by 2/3. Because that's the second power. We multiply by 2/3 to the second power. So I'm going to write it like this, actually. 2/3 to the second power. Looks a little weird, right? So the area of the dilation is going to be 2/3. I can try to do it a little better. 2/3 to the second power. Or let's do that. 2/3 to the second power. So 2/3 times 2/3 is 0.44444. Let's go ahead and just, I guess we can use that, right? 0.44 repeating. Also, if you prefer for this to be in fraction, you can just say 2/3 times 2/3, right? 2 times 2 is 4, 3 times 3 is 9. Let's go ahead and do that. Instead of putting 2/3 to the second power, could I see it here? We're going to put 4 nines, which is 0.44444, repeating, times as large. So 54 times 4 nines. 54 times 4 nines is 24. Oh, that was cool. So 24 square centimeters. So 54, we multiply that by 2/3 to the second power, or that's another way of writing it, right? 4 nines, or 0.44. So that's cool. I guess that's it. Thank you.